All right, happy Friday, everybody. We are going to be talking about glaciers. Glaciers are really cool. All right, so maybe you saw the video that I posted earlier this week. It's on our YouTube thing as well about how you can make one of your own. I'm going to post it in this lesson. I hope you do. It's a lot of fun. All right, so I want you to take a look at this picture of this glacier, and I want you to pause the video when I'm done here. Take a look at this, and just what do you notice here? And if I were to ask you, why do you think this part here is not quite as dirty as this front end right here? So the thing that is great about glaciers, and I want you to think about them, they are exactly like this. So if I were to go back and forth between these two pictures, and this is something, we're not going to write anything down today. We're just going to have a conversation about it. So you may be conversing with your, like I said, your cat or your dog or your grandma or baby sister, whoever. So whomever is in the room with you right now, talk to them. So if I show you this and I go back here, and I said that this glacier is just like this bulldozer, why do you think I'm saying that? And here's the other neat thing about this, and think about this. If I were to take you to a construction site, how and the construction site was empty. Let's say there is nobody working that day, and let's just say that there are no bulldozers anymore. They're just gone. Would you be able to tell where those bulldozers had been before? Maybe you're thinking, okay, well, I can see these tracks over here. You know what? There's no bulldozer here, but I can see the tracks where it had gone. So if I see these tracks, I know the bulldozer has gone that way or not. I can also see if that bulldozer is gone, it's going to leave behind that pile of dirt. If I get in that bulldozer and drive away, this dirt is just not going to magically spread itself evenly back out where it came from. So all of those ideas of how we would know where the bulldozers had been without them actually being there on the construction site, it's the same deal with the glaciers. We can tell where a glacier has been based off of evidence that it leaves behind. And if you think about this terminal end of the glacier, that's what we call the end of a glacier, is so dirty compared to back here because this is the front of the bulldozer. That's where it's pushing everything. This isn't dirty because it hasn't gotten there yet. Now eventually it will come down that way, right? And pick up that sediment. But for right now, it's not dirty because it hasn't picked anything up yet. So let's take a look at this. Now this website here, this is a video. I'm not going to show it to you here because the resolution is not very good when I do it that way. I'm going to link it here. I want you to watch this video. It's only a minute and a minute 48, so it's almost 2 minutes long. There's some really good detail in here about glaciers and how they work and how they form. I want you to watch this video, but I want to show it to you in a screen where it's not going to be all blurry and crazy looking. So do watch this video, please. Right? So we can see here, they mentioned in that video that glaciers are rivers of ice, mountains of ice. This is a great description of that. So if you imagine back this way, there's this massive ice field that with all this weight and pressure, and I mentioned this before in another video, where if you imagine like when a car drives over some snow and compacts it down and it gets kind of like slippery and it just gets compact, right? That's what happens if all this weight and pressure. So we have this nice combination of just the right amount snowfall with just enough melting, and then it starts to flow. So this is a slow process. It could take hundreds of years for ice here to make it down here. So if you look at it, this is ice that is flowing out of this mountain and spilling out this way. Now, if this glacier were to melt, it would leave behind traces that it had been there. Here's another one, right? So you can see where this massive ice field and then it's spreading out. Look how dirty that is from all the sediment that it's pushed out, like the blade of a bulldozer, and it's taking it out this way. This video, there we go. We're always a fan of the Here we go. All right. Watch this video. Also a great video that goes into what glaciers are and how they work. Okay, I'm going to have you watch that. Here, this guy shows us the top of a glacier, and then he goes down to shows us some of the melt, and then shows where it ends. Okay, and what that looks like. So great video here as well. Watch that when you get to it. Okay. All right, moving on here. There's another shot of a glacial area. Do you see a lot of trees in that area? Why do you think you wouldn't see a lot of trees in an area like that? And while I'm pausing here, this would be like turn and talk. So turn and talk to somebody. Here's a great diagram of glaciers and different style of glaciers and how they flow. It's another shot. Now here's to give you a scale of this. Down there at the bottom, it won't let me show you if I'm moving my mouse, but down there in the bottom in the water is a cruise ship. So this gives you an idea of the size of a glacier. Now, when we're talking about these glaciers, these are huge, but they are really actually nothing in comparison to the glaciers we used to have covering almost all of North America and Europe during what we would say is the ice age. Technically, we're still in an ice age because we have glaciers, but we're talking about like the maximum ice age. So look at all that sediment that's been picked up. This is part of the glacier as well. And that cruise ship down there is very small in comparison. So this is one of the things that's left behind by glaciers when they melt. This is a U-shaped valley. So if I go back, imagine this. If we took this glacier and if it were to melt, it would leave behind a valley that looks like this U-shaped valley with these nice curved sides, and they have been curved and carved out, weathered away by that slowly flowing river of ice. So if you imagine, I mean, these are mountains. This is not some little hillside. This is a mountain. And if you imagine it going from here to here and filling in this area of ice, that glacier right there carved that out. So look, this one right here, this modern day glacier is carving out a valley just like this one. There used to be a glacier here. We can tell because this U-shaped valley, that's one of the signs of it. It would have looked just like this. All right, so this is another piece of evidence of where we know glaciers used to be. It's called glacial scouring. And if you look at these rocks, they have evidence of glacial scouring. And I mentioned this example before when I talked about Kelly's Island in science. When I was a kid and I had a pebble stuck in my shoe, I thought it sounded neat when I walked around my kitchen. And then I looked down and I noticed that I was leaving these scratch marks in the kitchen floor. And that should have been a sign to me to stop doing what I was doing, but I didn't. And I left more scratches and I got in trouble. I left glacial scouring because these glaciers, when they're moving, they are going to pick up a rock and that rock will move with them. And as that rock is moving, it's going to scrape across the stone and leave marks behind. Here's one. This is in Central Park in New York City. This is a great example of glacial scouring. This gigantic boulder was in the ground, too big for the glacier to pick up, so the glacier just went over it and had rocks in it that left these marks. Looking at these marks, we can tell the direction the glacier was going in. So this is like the tread marks of a bulldozer left in the construction site, but it's a glacier. Kelly's Island is world famous for having the largest glacial scour marks in the world. So Kelly's Island is in northern Ohio in Lake Erie, which is left behind by the glacier as well. And these marks are evidence of just massive boulders that would have been drug across this softer limestone and left these marks. So glacial scour marks are proof of glaciers. Here's another one, glacial erratics. Glacial, meaning they come from a glacier. Erratic means that they're weird. They don't belong there. They're not supposed to be there, like this gigantic boulder that this guy is standing next to. This boulder does not belong in that area. These rocks even count as glacial erratic. So they don't have to be these massive sized things. They can be smaller sizes as well. So when we see something like this, if you look at that surrounding area, that area is really flat. And then out of nowhere, you have this gigantic boulder. That is because this boulder at some point was picked up by a glacier, moved along with the glacier, and when the glacier melted, when all that ice melted, that rock was left behind. It was deposited. So we know a glacier got there because the land around it is flat. That's another proof of glaciers. And we have this glacial erratic there. Here's another one. And here's the largest glacial erratic. It is about 16,500 tons, which works out to be 33 million pounds. That's an estimate from that. So this was picked up and deposited by a glacier. Here's another neat thing about glaciers. During the time of the maximum ice age, we had these amazing ice age mammals like a woolly mammoth. And sometimes they are also trapped inside of a glacier. And when those glaciers melt, we find the bodies. Now, it's not like in a movie where the ice melts and the animal comes back to life and runs through the city, but it will save things like the hair of that baby woolly mammoth. It's mostly younger ones because they would get trapped into ponds or mud holes easier. But we now know the fur color of woolly mammoth calves. We can now look at their skin. We can study their teeth. We can study the contents of their stomach and see what they ate last. This animal literally is frozen in time, and we have proof that we would not have from anything else, like bones, for example. And in this case, this is a block of ice that has been cut out of a glacier because somebody observed these tusks coming out. Inside here is the body of a full-grown woolly mammoth that they're going to take back to a laboratory. I don't know how you can notice how they're dressed, but when they take these animals back to a lab, they have to take them back to a laboratory that's inside of a freezer, because if they put them in a normal room, they're going to thaw out too quick and rot right away. So they have to keep them cold. It's like putting meat in your freezer, right? You can keep a meatloaf in your freezer for a really long time. My grandma did that. She kept meatloaf in her freezer forever. And then you can keep it in there. It's going to get nasty, but it's going to keep, right? And if you take it out, it's going to start rotting pretty fast. This is the body of a woolly rhinoceros calf that was found in a glacial area in Europe. So there used to be a species of animal, woolly rhino. Here's the eye, here's the horn, here's the mouth, and here's the fur color. This was the first that was found. Here's even the underside of the foot. Here's the face of a frozen cave lion found, calf. So glaciers are amazing. They can give us all sorts of evidence that they were there and evidence of animals that lived around them and were trapped. But then here's another thing that's going on with glaciers, unfortunately. Within the last 20 years, we are noticing that, not even 20 years, but we are noticing that glaciers are melting faster than they should be. Here's a glacier before, here's a glacier after. Same place. With glaciers melting this quickly, it has many, many changes to the environment around them. The animals that rely on colder environments will have a harder time surviving. And then on top of that, it also has an effect on the environment of the world overall. stronger than normal storms, drier than normal summers, wetter than normal seasons, which is not good in some cases. So this is a case of what's happening. Here's another example. Here's a before, here's the after. You can see the size of this thing. For that much ice to be melting that quickly, that is not a good thing. And then here's another shot. In this last video here goes into more detail about glaciers in a place here in the United States called Glacier National Park, which I've had a chance to go to. It's absolutely beautiful. Named that for the number of glaciers that are in the area, but are unfortunately now melting faster than they should be. And here's what I want to show you. This is where we're going to start tying into our unit on fossils. So when we think about the Ice Age, that is something that happened tens of thousands of years ago. Was the end of it. And here's this. Look at this one here real quick. We have glaciers now, but not like what we used to then. This is what North America looked like back during the Ice Age. All of Canada and a portion of the United States now was covered in one solid glacier. This glacier, we estimate, was so heavy that when it was pushing down on this part of the crust, it lifted up the bottom portion of North America up. So imagine if you're pushing down on a bathtub toy. You push down on one end, the other end bobs up. We have rock and fossil evidence in Florida that there used to be more dry land in Florida than there is now because this ice sheet was so heavy. It was pushing down on this part of the continent and lifting this side up. And when it melted, it released that pressure, and that meltwater drained out into the oceans and increased ocean levels. Here for Ohio, this is what it worked out to, and I showed you this on our our Ohio sites. Just about everything in Ohio is the way it is because we were covered in a glacier at one point. All of this part of Ohio is really flat because a glacier was there and flattened it. Everything here in Ohio is really good for farming because when that ice melted, it left behind sediment that made it good for farming. Kentucky is down around here. Kentucky's really hilly and mountainous because the glacier never got there. This part of Ohio is really good for coal mining because of all the mountains and coal that's there because the glacier never got there. So everything in Ohio is the way it is basically because of the glacier. We have Great Lakes because of the glacier. We have, like I said, flat land for farming because of that. So this is what happened to us during the Ice Age, right? If you think about like the Rocky Mountains in Tennessee, Rocky Mountains are over here. Smoky Mountains in Tennessee, they're there because the glacier never scraped them flat. If the glacier had gone further, who knows? The Smoky Mountains wouldn't be there because that's how strong glaciers can be. They can be just like a bulldozer scraping everything flat. All right, and that is a quick view of glaciers. I hope you guys make your own glacier. I'm taking pictures of my glacier that I made by the hour so I can see the changes, and then I'll be posting those up so you guys can see them. If you make your own glacier using the video that I shared, please share videos if you can, or pictures. I would love to see pictures of your glacier that you made. That would just be really neat to see. I hope you guys have a great day, and I will talk to you later.